This is a video for MEI Core Pure Mathematics, Vectors 5, Further Lines and Planes, 5.7, the perpendicular distance between skew lines. It's worth reminding ourselves what we mean by skew lines. If you have a look at the picture, the lower road, the motorway, is in this direction, and the upper road on the road bridge above is in this direction. And these two lines are clearly not parallel. However, they don't intersect. And we can see that because the traffic that's travelling along this road will not hit traffic that's travelling on the bridge above. In order to find the shortest distance between these two skew lines, we want a line which is perpendicular to both, and then find the distance along that line. We can't use our ordinary distance function that we used in previous videos because that didn't take account of the fact that these two lines are skew. Let's have a look at this in diagrammatic form. I've got here two lines, L1 in red and L2 in green, and they're clearly skew lines. The equation for L1 is here. It's got a known point A1 and a direction D1, and L2 is here with a known point A2 and a direction D2. So this point is the known point on L2 and this point is the known point on L1, and these are their direction vectors. The pink plane, pi1, contains L1 and is parallel to L2. And similarly, the green plane, pi2, contains L2 and is parallel to L1. And these two planes, therefore, have to be parallel. Now, the distance I want is the distance here. P and Q are 2 points, one on the pink plane and one on the green plane, and the line that connects them is perpendicular to L2 and perpendicular to L1. So that's the distance that I want. And because these planes are parallel, that's the same as this distance here, A2 to N. I've got here a normal vector to the planes, and because they're parallel, it's the same normal vector. And I've actually got this as a unit vector. And to get that unit vector, I need to do the cross product of d1, d2 and divide by the length of d1 cross d2. So that's this thing here. So to get this length, a2 to n, I'm going to do this line, a2, a1, cos theta. And if we've got cos theta, that involves a dot product. So PQ will be n dot a2, a1, the vector between a2 and a1, and I just want the length of it, so I've got the modulus of that. So putting those together, a2, a1 is just a1 minus a2 here, and this unit normal vector is just d1 cross d2 over the length of d1 cross d2. That's this thing over here. If you want more explanation for this, then I would suggest that you have a look at your textbook or you have a look online. Let's have a look at an example involving this then. Let's call this L1 and this L2, so two lines. They're not parallel, and it turns out they don't intersect either. Call this A1 and this D1 and this A2 and this D2. Then let's start building the bits that we need. The first thing we want is D1 cross D2, and that's going to be minus 1, 3, 4 cross 0, 3, 2. and that gives me 6, take away 12 is just minus 6. Nothing, take away minus 2 is 2, and minus 3, take away nothing is minus 3. Now the length of that will be just the square root of minus 6 squared plus 2 squared plus minus 3 squared. 36 plus 4 plus 9 is 49, so this thing is going to be root 49, which is just 7. So we've got this and we've got this. The final bit of the puzzle then is the a1 minus a2, so let's just calculate a1 minus a2. That's going to be 1 minus 1, 2, take away 2 minus 4, 0. And that gives me minus 1, 3, 2. And so now my distance is just going to be this vector, minus 6, 2, minus 3, dot, minus 1, 3, 2, all over 7. This gives me 6 plus 6 minus 6 all over 7, and of course I want the modulus of that, and that is just 6 over 7. There's a slightly neater write-up of that. Here's the d1 cross d2 thing, and then the a1 minus a2, so that was the 1 minus 1, 2, take away 2 minus 4, 0 thing is down here. The dot product comes out to be 6 plus 6 minus 6 as we saw before, and that gives me my final result of 6/7. So the technique is to identify the direction vectors and the known point vectors on each of the lines, construct the pieces, and then stick them into this formula. Don't forget that you have got a big modulus around the outside to make sure that you end up with a positive result for the distance. That was the final video in this sequence, Vectors 5, Further Lines and Planes.